Good afternoon, everyone. This is Adrian Pace here from the IEEE Foundation, and it's a pleasure to welcome you to a Humanitarian Technology Webinar on product development for the other 90%, lessons learned by Peter Haas of the AIDG, where he is Executive Director.
Started.
So the Humanitarian Technology Webinar series is offered by the IEEE, of course, and it's free and publicly available to anyone who may be interested, whether you have a technical background or whether you're a social entrepreneur or from an NGO or government or even from industry as well. And the intent is to make this a powerfully engaging webinar series focused on applying technology to solve the world's most pressing humanitarian and development challenges. This is actually our 9th webinar since we began about a year ago. And if you go to the website, which is on this page, you will find archives of the previous webinars. And we've had some really great webinars. We started off with one from the World Wide Web Foundation regarding mobile web technology for the developing world by Max Fremonta. And since then, we've had various webinars relating to entrepreneurship within the tech community in Nairobi, sustainable electrification solutions, and water solutions for developing countries. We've had a webinar about Engineering for Change, which is a platform for engineers to engage with each other in developing solutions for those who need it most. We've had one on a solution by a group of students from New Zealand, which actually won a Microsoft Challenge competition to do with sending educational data via radio waves. And most recently, we've had Fikir van Stam from Macho Works in Zambia talk about internet access in rural Africa, and another great initiative on fighting counterfeit drugs using mobile technologies by Sproxo. So the webinar is, the series is run by a team of volunteers and is supported by staff in New Jersey, Steve Welch and Alex Torres from New Jersey. And this is an initiative of the IEEE Humanitarian Ad Hoc Committee, which is chaired by Amarnath Raja from India. Well, just a few housekeeping issues before we start. This is a webinar, and it's important that we manage our interaction very, very carefully. Firstly, it would be great if you could enter on your name and location in the Q&A window, in the chat window, which you can find to the left-hand side at the bottom. That way we get an idea of where we're from, and I'm pretty sure we'll have people from all over the world. We have 25 people in the room right now, which is a great turnout. During the webinar, please enter any questions you have in the Q&A window. I will gather these questions and I will ask these questions to Peter at the end of the session. After the webinar, please return to the website to receive your personalized certificate of completion, which gives you 1 professional development hour. Apart from that, I think we're almost ready to go. I see people calling in from Canada, US, Kenya, and Colombia. So we've got, and I'm in Europe, so we've got Google and China is there as well. So we've got almost all continents covered. The next webinar is actually by a colleague of mine from where I work in the Netherlands. I work for TNO, and this is about a study, and it's called Leveraging ICT Business Models to Help Reduce Poverty by Binica Posthumus. What was done in this piece of work was an evaluation of, I think, around 280 different information and communication technology businesses on the ground, which in developing countries, to find out what are the key elements of sustainability, because sustainability is always a key question in initiatives that are targeted at those who need it most. And so this is a great study, and Binika will present this in January. In case you're not an IEEE member, then please do become one. We are a network of 400,000 members around the world, the largest professional society in the world, and we have a great number of initiatives targeted to the humanitarian space, one of which is a partnership with ASME, the American Association for American Society for Mechanical Engineers, which is called Engineering for Change. Well, now finally onto today's webinar. I hope that you have abandoned me talking for a few minutes, but after this you won't hear much more of me, because Peter Haas will be talking about product development for the other 90%, lessons learned. And it is really a great privilege to have Peter talk to us today. Since founding AIDG, an NGO that supports small infrastructure companies in Haiti and Guatemala in 2005, Peter has become an active voice for poverty issues, speaking at the World Bank, Harvard, MIT, and other forums on technology, entrepreneurship, and SME finance. His work with AIDG has been featured in Fast Company, Popular Mechanics, NPR, and Forbes. He has served as a judge for the EPA's People, Prosperity, and the Planet competition. He was a 2006 Echo and Green Fellow, a 2008 Walsall Institute Architect of the Future, and a 2010 TED Senior Fellow. His work in Haiti has been highlighted by the Clinton Global Initiative. Before founding AIDG, he worked both in the information technology field and on an organic farm and horse ranch doing infrastructure improvement work. Peter is also principal at 50 Frogs, a small invention firm. He tinkers in water systems, sanitation systems, renewable energy, and sustainable building. He received a BA from Yale University in philosophy and psychology in 1998. So Peter, once again, we're very pleased that you could give this webinar today, and it's over to you now.
Thank you. Can everybody hear me?
Yes, we can.
Okay, great. I just wanted to check that before I started in. So I want to give you a little background on AIDG before I got started. AIDG is a not-for-profit that I started in 2004, which focuses on appropriate technology and giving appropriate technology solutions out to populations in Haiti and Guatemala. We did this through two major programs through 2010. We ran a research and development program that worked with universities, private inventors, different NGOs, and private corporations to try and develop new technologies and address refurbishing old technologies for the BOP. And we also do a business incubation program that helps start companies that are implementing these technologies and gives them seed capital and 2 years of training to get their business off the ground and start serving populations. We have worked with a range of technologies, hydroelectric, wind, solar, biogas, different biofuels. So there's a great breadth of experience that we're drawing from in giving this talk. And we've worked with a range of different groups from the commercial to the nonprofit. So in this talk, my hope is to give you some background on some of the pitfalls that we see commonly in groups trying to do product development for the other 90%, and hopefully some suggestions on how to avoid those pitfalls and develop really great products. So just to give some background, we did Pelton wheel systems and hydroelectric turbines. We developed load controllers for small-scale hydroelectric systems. This is up to a 50 kilowatt load controller. We developed biogas systems. We developed solar hot water systems. We developed hydraulic ram pumps. We did stoves. And internally, we did a fair number of technologies. My goal right now is to talk about what we did with other groups, though, primarily, because I think their experience mirrors what you're going to go through. This is a photo of one of the most popular inventions that ever came out of our program. It's the bucket hydro pico power system. And this system receives currently the top web traffic for anything on our website. It's been consistently drawing thousands of people to our site for the past couple of years. And it was the brainchild of this fellow here, Sam Redfield, who's a private inventor who worked in the film industry, and one day got an idea for a new product to do pico hydro for emerging markets. And he contacted us and said, "Hey, can I field test this with you?" And we said, "Yeah, this looks like an interesting product," and we moved forward with him. But basically, this product is a pico turbine. And as you can see, this turbine is made entirely of PVC parts. It's just cut PVC tube that's making the turbine, and PVC components going into the bucket casing. The problem with this was that though the turbine is cheap, the generator itself is actually a pretty expensive thing. And this is the first pitfall that I want to talk about. Sam Redfield developed a cord PMA, which is permanent magnet alternator, for this system to be able to increase the voltage output of the alternator. So those not familiar with permanent magnet alternators, you're basically taking an alternator, you're removing the wiring from the central core, and you're recoiling it with magnets that can allow for higher amperage and voltage generation coming out of the alternator. So you get more power out of a stock alternator. Unfortunately, the PMA cord alternator ended up pushing the cost of this system to several $100s from a system that could have been $150. And this is something that is really core in developing for the other 90%, is trying to develop products with a price point that is hyper affordable. And even though this invention looks like it's hyper affordable, it's in a 5-gallon bucket, it uses PVC parts. When you take the alternator core and you take the circuitry that's used for the charge controlling as a result of using a cord alternator, the price of the system gets beyond most for what small farmers could afford for a system that would be used for battery charging of cell phones, for maybe a TV, only a few hundred watts output. So that's lesson number one in doing design for the other 90%, is really to make sure that you're always focused on hyper affordability, to really focus on products that people can pay for either with a microloan or out of their pockets, and not to focus on trying to get the most amperage or wattage that you can out of a device, or gain the efficiency of the device to the highest level. This is something that engineers who have a training in the US and Europe have a hard time doing. We've worked with a lot of engineers who in the US make great designs, but then when they get down into country, those designs end up being not as affordable. The ultimate cost of this, I believe, was $240 US. So speaking of engineers in the U.S. coming in with a design, I thought I'd share an example of a typical college design team. So this is a solar fridge designed by Michigan State University. And they came to us with the solar fridge, wanting to do the design. And we thought it looked pretty good, so we let them come down and work in our shop. And they pulled together the solar fridge in the course of a week. They got a really nice photo with the fridge, and then there was no follow-up. Unfortunately, there's a lot of college design that ends up like this. It is a spring break trip for the university students, and they don't have a plan for placement communities, field testing, gathering data, getting feedback from the community. And at the core, when you're doing design for the other 90%, it's feedback from the community and the end user that really is what is needed to determine the success or failure of your product. It's something that honestly not enough groups design with a focus to, and in judging the EPA P3 competition, run across a lot of designs like this, designs where the group goes in and they're working with the community for a spring break period, and then ultimately they just don't have the long-term connections and contacts to be able to pull the design off. So if you're working in a university setting, I think one of the key things to focus on is developing long-term community presence and long-term ability to go back every 6 months or so and check in on the design, get feedback, get the data from the community that you need to be able to determine a good design. So this is another university project. This is a UC Berkeley solar water heater. And this design was another that was a university team coming back, but this university team not only did their design up in the States, but they did a very good job of getting it out into communities. And they developed a multi-year strategy for getting this product out into test areas. The one drawback that I saw with this was that as a result of getting the product out into communities, they were convinced of success early on. And they started getting media and press in places like CNN, where they were still only working with a prototype. And this is another pitfall, and you wouldn't think of this as a pitfall to get media or press, but I've seen a lot of vaporware get media and press in the design for the other 90% world. Things that are out there as images or test products, but not out there as something that can be purchased. And I think that that's something that is very cautionary, because in the end, this team ran into a design flaw whereby the bladder would actually develop leaks from bubbles that were superheated that would burn through the permeable, or burn through the bladder membrane. And though the bladder was designed to withstand the temperature of the hot water, it couldn't withstand the temperature of these superheated bubbles. So in the end, that caused failures in their system. And it was something that they hadn't predicted would happen. And it was something that ultimately really hit the product and slowed down product development. And I think that this is a cautionary lesson for all groups that are trying to do design for the other 90%, is to really be clear if you're getting media that you still have a prototype when you have a prototype, and not provide something that you're presenting as a finished product. So to another design that got a lot of attention, this is a contract from a private company, Humdinger Wind Energy, that had developed a product. They'd gotten venture capital, and it was a vibrational wind generator that was very low cost. Now, this follows a core design principle. The designer of this was looking at wind turbines and looking at how to get a turbine down under $1 or $2, and realized that with a turbine, you couldn't get it down that cheap. The bearings and the moving parts alone were going to just push up your price, and you can't develop a micro turbine for wind. So the inventors started investigating the Tacoma Narrows bridge effect and aeroelastic flutter, and realized that if you leveraged aeroelastic flutter on a small scale, you could move a magnet within coils and generate enough electricity to do cell-phone charging at a very inexpensive price point, and we could outproduce small-scale solar panels with a small-scale wind generator. This generator got a lot of accolades. It won Popular Mechanics Innovation Awards in 2007, and it was something that was poised or looked, again, as a prototype, like something that would take off and spread to a lot of countries. So we got a contract to test the scale of the effects, and we developed a tower system, set up a monitoring station, and set up remote monitoring that would allow the inventor from Hong Kong to do monitoring at a test facility in Guatemala. And this is something that permitted them, even though they weren't present, to have constant interaction with the test location and with the local talent that was providing the services, doing the testing for them. This type of interaction, I think, is a model for how you can set up communication even if you are at geographic distance with testing apparatus. This specific example, the Skype interface, you could actually Skype directly to the tower and ask the tower what the weather conditions were, what the voltage was, and the tower would respond to you by Skype without having to interact with the local workers. And you could get that data any time of day. So this shows that, you know, modern information communications technology has solved a lot of the distance gap, and it is possible to do interaction at a great distance, even getting webcam and video at a great distance to be able to do your product design and check in with communities and do testing. So this is a positive. Ultimately, the product did not go to manufacture. After the testing, the data on the product showed intermittent generation at low wind speeds, and it was shelved for a period of time while they're doing revisions on the product before trying to take it to market. But I want to share this example as, again, an example of the ability to communicate over great distances and be able to have community interaction and get feedback on your product and get testing done. So the ultimate result of this is the product is looking at developing wind cell panels with multiple small vibrational belts instead of doing a large belt. So I want to talk now about some work that's being done by other groups. And this is an example of an incubator that was being done by Design That Matters, based here out of Boston. And it's called the Car Parts Incubator. And this is an attempt to try to address the fact that incubators generally cost $20,000 US. Just lost my slide here. Hold on one sec. I'm going to go back. Incubators generally cost about $20,000 and are not affordable for most ICUs and most neonatal care units in emerging markets. And so the Design That Matters team addressed this problem by trying to see what parts could be leveraged from the local stream of auto parts to be able to develop a technology for an incubator. They developed this incubator. This costs a few $1,000s, and it looks like a really good solution until you take a look at this. And this is the Embrace incubator that came out of the Stanford Design for Extreme Affordability course. The Embrace incubator takes the problem of incubation down to its core. What is needed to keep the baby warm? And by doing that, they're able to strip out 90% of the materials. In the sleeping bag, there's phase change material that goes into the sleeping bag that's heated in an external heater that can hold warmth, I believe, for 12 hours. I need to verify that figure. But this is one of the core lessons when designing for extreme affordability. If you're designing for the other 90%, you should strip off 90% of the materials. See what you can do when you take away 90% of the materials and cut down the cost. And there's a link for Embrace Global, which is in the chat, if anybody's curious about this incubator. Embrace is another group that has gotten a lot of press, but to their credit, the press has been stating that this is a design that's in testing and has been really clear that they're working on the design and that it's a prototype, and they've been working towards getting full production and distribution. The other thing which is nice about the Embrace team is they have a team dedicated towards commercialization. Okay, so this team is working towards developing a company that can produce this at a large scale, that can address local issues of medical devices, and can get the product into production and into the marketplace. I personally am not well versed in the challenges Embrace is faced with local medical device regulation, but I'm sure that if you contact Embrace, they could chat with you about that. Now, it's not only startups that are trying to enter the field of design for the other 90%. This is an example of a stove product that was developed by Siemens, the Proto stove. Now, Siemens worked in collaboration with a university professor who had been doing testing for the past 4 or 5 years to try and take his invention, his product, and commercialize it at a large scale. The Proto stove has seen mixed success, I'd say. They've faced a lot of challenges in their target markets with distribution and with production. Being a large company doesn't mean that you necessarily know 100% how to get things out in developing economies and do production in developing economies. I think that one problem that Siemens faced was they tried to centralize their production in the areas of distribution, which is something that may not be the best solution for the product you're trying to make, depending on what the product is. The proto stove has a lot of high precision machining that's involved in the product development that may have made it a better candidate for mass production in China and then distribution to the target markets. And here's a nice look at the proto stove. Again, it's a vegetable oil stove, so it's something that people can find fuel for all over the place. It's also very well designed, and this is something in terms of just an appearance, designing for beauty framework. The proto stove definitely typifies the don't give people junk if they're in emerging markets, just because they're in emerging markets. A lot of the devices that people make for emerging markets are kind of weldments. You see a lot of people designing things that look like junk, and I'd say if you can avoid that and design something beautiful, you should try to design something beautiful. Here's another example of a product series that was designed specifically for the BOP. This is the D-Light light series. The thing which is nice about D-Light is they looked at existing technologies and adapted the existing technologies, set up manufacturing in China, started mass producing them, and D-Light is now serving millions of customers worldwide. They had a very short research and development cycle that had very clear goals, and they're able to get their products to the market. And this is really the goal for all of us who are doing product design for the other 90%, is to see how we can get things to market and get things to market at scale. And again, a lot of designers get caught up in the design, and they lose track of getting things to market. And speaking of getting things to market, here is the IDE treadle pump, which is similar to the Kickstart treadle pump, which between the two have affected tens of millions of lives across the world. The treadle pump is a simple invention that's been around since the 60s, even before the 60s, but mass-produced by appropriate technology groups in the 60s and well documented. And it's something that just shows that, you know, there are a lot of designs that are out there that exist that if you can adapt them and get them to market, you can have a huge impact on people's lives. The thing which is nice about the treadle pump is it makes people money. For Kickstart, they call it the moneymaker pump. And it allows small farmers to invest in the pump, make back their investment, get more money, and then be able to reinvest that money in other things, such as education or lighting. IDE took a really radical shift with the treadle pump to make it even more accessible to more stakeholder farmers. They developed a version of the treadle pump that is following the principle of removing 90% of the material. So there's a scaled down, cheaper version of the treadle pump that's available, and the cheaper version increased, I'm not sure the exact number, but significantly their reach within India. So speaking to the idea of technology that's already existing and adapting it. I will bring up one of the examples of one of the companies that we've invested in, which is DOE Green Enterprises. And DOE is producing a stove for the Haitian market that is capable of reducing charcoal production by 50%. Now, for those familiar, they may recognize the stove. This is actually a ceramic Gico stove that has been used in Kenya and other places around the world for years. This has simply never existed in Haiti. And this is one of the things that's really important about design for the other 90%, is there are a lot of solutions out there that already work in other places that can be replicated. You don't have to reinvent the wheel. You don't have to develop a new stove every time you enter a new market. And the founder of this company realized that, saw the stove in Africa, realized it would be a great stove for the Haitian market, started with a production run of 10,000, sold those, got investment from us, is working on other investment, and has a goal of selling 300,000 stoves in the next 3 years. And I think that type of adaptation has worlds of possibility for spreading appropriate technology solutions across the world. There are things like corn shellers that you can get in Malawi that you can't get in Guatemala. And there are things like treadle pumps that you can get in Kenya that it's really hard to find if you're in Haiti. So I think that looking at your project and looking at what's out there first is very important towards developing a viable commercial product. And here are just some more copies of the stoves, and here are stoves being distributed. So I got through my talk a little bit sooner than I had thought. We're getting a bit more time for questions, but I wanted to open it up now for questions from the audience, and thank you for viewing. I really appreciate the audience.
Okay, thank you very much, Peter. Adrian here again. I missed much of your webinar because somehow I got kicked out of the platform. So I'm a bit behind compared to everyone else. What I suggest is, Alex, if you're comfortable, could you pose the questions for Peter? But thank you very much, Peter. Okay, it looks like Alex is typing in the questions here, so just bear with me. Here's a question. Have any designs intentionally involved local technical schools and local talent?
Yeah, so most of the work that we did was with local technical schools and local talent. In fact, that whole contract with Humdinger Wind was pretty much all done by local talent. There weren't a lot of U.S. Team members in that team. And I think that there's a lot of opportunity for local inventors to get their products out. I think one of the biggest challenges to local inventors is really access to capital to be able to get their invention out into the marketplace. And we'll work on that, and there are other groups that work on that. but local inventors really have a keen sense for what is needed. We did an investment in a company that is in Guatemala that has developed an energy regulator for electric hot water heaters on shower heads. And they were very keenly aware of the energy usage of the local hot water heaters that go on the heads of showers. And they realized that they could cut that energy usage with a pulse system by about 30%. And I think that there need to be more local inventors like that out there, and there are more programs springing up that are trying to sponsor local inventors and help them get their ideas out there.
So, just to follow up to that answer, how many of your projects right now are really driven or led by entrepreneurs locally who come up with an idea and to say, yeah, we need some investment or some support for this idea? Is it that the vast majority are done by them, or is it coming from overseas mainly?
Right now, since we closed down our internship program, it's 100% local. All the ideas and all of the talent is coming from local entrepreneurs.
I think that's fantastic. Next question. This comes from Iana, and she has a question. Have there been any modifications to the stoves for Haiti to make it sort of appropriate for the Haitian market?
Actually, the Gico stove for Haiti is pretty much the same as a Gico stove that you'd see in Kenya. He did almost no modifications for the Haitian market. It's just much more efficient than the traditional Haitian stove. Though similar, it's very familiar to people who are used to using the traditional Haitian stove, which is basically a steel stove that lacks the ceramic liner, and the ceramic liner is what really contributes to the efficiency.
Another question. Is there other platforms for enabling local inventors rather than, relying on a developed world local inventor interaction purely? Are there sort of hubs on the ground where inventors get together and exchange ideas?
There are programs and hubs. I mean, the biggest, most widely known program is probably the Maker Faire Africa program, which really gives a chance for local inventors to showcase their products. And there have been examples of people who are local investors going to Maker Faire Africa and looking for inventions. But I think that the whole sector of support for local inventors is something that's very new, and it's not something that's getting a lot of wide support. And I think that's something that's going to change in the next couple of years.
Yeah, because I see this piece of local innovation, and, it's key for the future in terms of economic development for many of the developing countries. And that's why I really appreciate the questions that have come in today, because a lot of them have been focused on that aspect. Another question I see here is, in medical devices, a big challenge is getting the decision makers to want to purchase locally produced products. They often prefer Western products. Do you face this in any of your projects, and if so, how do you address it?
We currently don't work with medical devices. I was just giving the examples of Design That Matters and Embrace as two organizations that do work in that field. I believe that Embrace has a team specifically dedicated to regulation. And this gets down to the designing things that look nice and modern and are high tech that could be wanted in the developing world. If you can design something that really looks like it's cutting edge, I think that helps with adoption by local regulators and people locally. We had the same sort of issue with developing our hydroelectric controllers. We had some not as clean looking hydroelectric controllers when we first started. There was a lack of confidence in them, even though the electronics was fine. We cleaned up the electronics, made the presentation nicer, and were able to get increased sales of the hydroelectric controllers. So I think that, again, it gets back to that lesson that I was trying to stress with the proto stove. Make your design look nice, and make it look modern, and people will be interested in it.
Right, okay. And how do costs compare, both the cost of production and the cost of the stoves being sold, between the GECO and the Haitian stove?
The costs are very similar. The stove in Haiti sells for $9, and its cost of production and distribution is about $7. It's got about a $2 margin. So those are very similar costs to GECO stoves in Africa.
Another question from Alex, and he asks, do you see the design for the other 90% as its own field, or just as designed with atypical stakeholders and priorities?
That's a difficult question. I would say that it is a field in and of itself. It's something that requires a specialized focus among the designers, and I think that the real separating difference between designing for any other stakeholder is that with design for the other 90%, there's this extreme value in spending time with the stakeholders and kind of living the lifestyle for a little bit to get insight onto the design. And I think that that's something that there are very few other design populations where it's really as necessary to live the lifestyle for a bit and really try to understand where people are coming from. So I'd say that it's a pretty unique field. I mean, that's my subjective opinion. I'm sure there are lots of people who disagree with me.
Okay, and the next question from Alberto is an interesting one. How has your experience been with local governments? Have you had much interaction with them, and what has your experience been? But before you answer that, I just want to request the people attending, if you could just, while Peter is answering the question, if you could just type in the chat window where you heard about this webinar and try to be specific. Was it, through the Engineering for Change newsletter? Was it you just visited the website or did a Google search? It would be great because that would help us to reach out to more people in the future. But Peter, if you could please answer that question, your experience with local governments, please.
So far, our experience has been pretty positive with local governments. We've only had one product design that's really required any sort of national government intervention. That is a prefab housing system in Haiti. And that process went pretty well as well. Again, we're primarily working with the entrepreneurs to help entrepreneurs go through that process. So instead of us talking directly to the local government, it's local entrepreneurs talking to the local government, which I think is a slightly different process than having a foreign agency working with the local government.
Very interesting. Another question from Ismail, and that is, do you believe that a really good product is a product that is good everywhere, regardless of location?
I think that there are a lot of really good products that can have cross-market applications, both in developed world and emerging markets. I mean, the prime example of that would be, say, the cell phone. I don't think that the best product is going to be the same in every single market, just because the use cases are different. So a cell phone that's great in the US because it is something that's got a really nice touch screen and can play the latest apps, is not necessarily going to be the greatest cell phone in a place where you want a week of standby battery time and you want something that is readable in the sun and can survive lots of dust and water exposure. So I think that there are differences locally that need to be addressed when designing products. And honestly, the most important thing is not whether a product has an appeal over a really large area, it's whether a product has enough appeal to be able to make it viable financially. And there are plenty of niche markets out there that need products designed for them that could be viable financially that are missing products. So that's my answer. Some products, they definitely can be more universal appeal. I mean, the Gico stove is an example of that. Some products you really just want to go niche.
Okay, thank you. Folks, this is probably the last few minutes of this webinar, so if you have any more questions, then by all means, please type them in. There's a question here from David, and that is, do you think a shift in focus towards marketing and distribution models is needed amongst leaders in appropriate technology design organizations?
I would say 100%. I see in the EPA P3 competition way too much design that's reinvention of the wheel, where people are trying to just do the design aspect and they're trying to take a product that's already existing and tweak it or modify it and reinvent it. And honestly, it's gotten to the point where it would be much better to see more of that commercialized. I mean, people who are doing design for design's sake are losing track of why we need to do this. And we need to do this because 90% of the people out there don't have affordable products for cooking, lighting, housing, clean water, sanitation. And the goal is really to get them affordable products. And the best method for doing that is not just design, but a combination of design and commercialization.
Okay, Jennifer has had a question before, which I've just seen here. That is, it's hard to keep track of all the different projects and designs that exist out there because often people are just unaware. And as you say, they often end up reinventing the wheel. She follows Acropedia, which is a repository for such designs. Do you know of any others that are out there?
I think another very classic repository is the Village Earth Library. That's a huge appropriate technology library of most Village Earth, or most volunteers in technical assistance designs. So basically, designs that were used by the Peace Corps and by the British Volunteers in Technical Assistance Group got all collected into the Village Earth Library. So that's a good source. Apropedia is a good source. Sorry, I'm blanking on the name. The IEEE, which has now changed its name, book series, is a fantastic source for information. IEEE is a group out of England, and they now have a new name, Practical Action, thank you, which I'm blanking on. And that group produces a library series that is fantastic. It's old school paper resource. It's not digitally available, but it's got some of the best information on appropriate technology in the world.
Thanks. That's a useful tip. Lots of people are asking, because you mentioned quite a few different links there, and I'd like to know, is it possible for you to perhaps send an email after, just with the links to those organizations you mentioned? And then we'll put it on our website. No problem. Lots of people are interested in that.
No problem.
Thank you. Okay. A lot of, this one from Marijn, who in fact is a colleague of mine. He says, a lot of international companies and organizations are entering African markets. What opportunity or role do you see for African entrepreneurs themselves?
I think there are lots of potential roles for African entrepreneurs. I think that, honestly, if the venture capital market in Africa keeps on growing the way it's growing, there are going to be a lot of opportunities for local African entrepreneurs to take their products and designs out to market. And a good place for entrepreneurs to look is to investigate either the Aspen Network for Development Entrepreneurs, the Andy Network, or investigate the GIN Network, which is Global Investment Network. Both those groups have members that provide investment in various regions, and you have to go through the members one by one to figure out where they're providing investment. But there's a growing field of SME investment out there, and there are a lot of opportunities for African inventors to get venture capital and really start moving their business forward.
I think we have time for one last question. And Jennifer has just sent it. She says, in your answer about working with local governments, you say that it is the locals speaking to the local government. My experience in Africa shows that local leaders, i.e. high-level decision makers, prefer the opinion of outsiders. They do not listen to their own people, even if the argument is the same. You say this, and is there anything that can be done to shift this mentality?
I think that there are a lot of issues involved with entrepreneurs working with local governments, and it depends highly on who the entrepreneur is and what the education level of the entrepreneur is. We've had a lot of success with the entrepreneurs that we work with, working with local governments and being able to work their way through regulation. They've been able to do this largely because they're very well educated. And I think that education is one of the key determiners in how well you'll be able to interact with the local government. There's definitely issues of education and class in any dealings with governments in emerging markets, and it's something that is unfortunate in markets that have a lot of graft and corruption. But I think, again, an educated entrepreneur can do very well working with local markets, local governments.
Okay. Well, thank you, Peter. I think it's 5 o'clock over here in the Netherlands, so it's been an hour. And I'm getting lots of messages congratulating you for a really great webinar. Thanks so much for doing this. Not only do you do great work, but you're also a great speaker, and you're able to articulate what you do really, really well. And I think lots of people have, learned a lot of things through this webinar, and also have been put in touch with many useful resources. So again, we are really grateful for this opportunity to have you speak for us. And we will have a recorded version of this webinar available online at our website. It will also be archived on the YouTube channel for Engineering for Change. In case you've not been to Engineering for Change, it is a great platform for interaction and engagement and co-creation on technology for the developing world, for communities that need it most. So go to engineeringforchange.org. It's really great. And we have plans for this webinar series to be integrated within that platform, and that should happen very soon, within the next couple of months. So Peter, once again, thank you, and goodbye everyone. Great having you here, and join us for our next webinar on the 11th of January by Binika Kostumis on ICT business models for the developing world. Thank you, goodbye.
Thank you, goodbye.
Bye.